Hi everyone, so this is my attempt at solving problem number 1 of the Euler project. The purpose of this exercise today is to find the sum of all the multiples of 3 and 5 below 1000. So this is my naive attempt at solving this problem. So first, let's have a look at the requirements. We want to find all the numbers which are multiples of 3 and 5, and to get started we need to check that we are in check with the numbers below 10. So let's write a function that does exactly just the first line. So the first thing we should do is writing a test. So let's write a test that's validating the condition. So we are going to take the numbers from 0 to 10, and we want a function that returns successfully whether a number is indeed a multiple of 3 or 5. So tests is multiple. So if I write it here like test multiple pi. So imagine. So now let's imagine how this function would behave. So it would probably be called is multiple, and I would like to know is, for example, 3 is a multiple of 3, and I want to check this. So I'm using an assertion. Assert is going to do nothing if the expression after it returns true, and it's going to break if the expression after it returns false. So my function is multiple will return a Boolean value, and for the combination 3 and 3 should return true. So it should also say that 5 is a multiple of 5, but for example 3 should not be a multiple of 5. And something which is not good, so let's say that 6 is not a multiple of 4. Okay? So now we can write the actual code. So this is the test function here, and we're going to write a new function called so here def is multiple and takes two values, let's say number and factor, and let's have it do nothing for the moment. So I have my tests which tests 4 different combinations, and now if I do PyTest, so PyTest is going to load every file it finds which name starts with test underscore by default. And so now it's indeed loading my test is multiple file, test multiple.py, and within the test called test is multiple, it finds my assertion is multiple 3, 3, but it tells me, yeah, you know what, is multiple is not defined, so it's not gonna work. So what I should do here is, because of course it's within this module, but it's not in this module, it has no knowledge of what I've been doing on the other file. So now I have to import the is multiple name here from multiple import is multiple. So multiple points to this file, and I'm within test multiple. So test multiple has to import the name is multiple in this function. Okay, so now PyTest again. I say, okay, assertion error. It says, oh, is multiple 3, 3, returns none. Not true. How come? Oh yeah, of course it does nothing. So how can I say if a number is a multiple of another number? It's pretty easy. I just have to know if the modulo, so the remainder of the division of number by factor, equals 0. If this is the case, meaning if I can completely divide number by factor and it remains 0, then it means that number is a multiple of factor. So if number is a multiple of factor, then my function should return true. In every other case, it should return false. Now let's try. Oh. It says that 3 is not a multiple of 5, but it should be. Oh yeah, it's because my test is wrong. I'm asserting, so I want that 3 is a multiple of 3, 5 is a multiple of 5, but 3 should be detected as a multiple of 5? Nah. So I should invert my my assertion. Like assert that not is multiple 3 of 5 and not is multiple 6 of 4. Hey, it works. This is not the best way we could write our tests. As you can see, it's not... well, if it fails, it could fail here, or here, or here, or here. So the same test could fail in 4 different places, which is not super elegant. We could leverage something coming from PyTest. So I just import PyTest feature, and PyTest has a way of generating different test cases on the fly. So let's say we have like PyTest metrise, and then you have to pass the signature. So the signature is how many arguments this test function is gonna take. So it has a number and a factor, and then you have to pass all the number and factor that you want to test in a list. So 3, 3 and 5, 5 should work. Here I need to modify here, it's saying okay, an F for number and factor, and N work with F. Okay, now I can comment this whole part out. Now if I PyTest-V or verbose, it's going to tell me every test it has been generating. So you see now I have test multiple, and then even though I just have one single test is multiple, it generated one for 3, 3, one for 5, 5, which is great. So now my 5-line test has become 3-line test, and I can add as many cases as I want. So if I want to have like 4 is divisible by 2, yeah, sure, 4 divisible by 2. But would that work with my inversion of test of assertion? Like, say if 5 can be divided by 3, of course not. The good thing is now it's only going to point me which version of the test is failing, which is good. So I can immediately know which of my assertion failed. And it's telling me is multiple 5 and 3, and then and so it's repeating again. N is 5 and F is 3, which is great for getting straight to the point. But it's not really helpful here, because I would need to either store the direction, like is it straight assertion or is it reverse assertion. So I can duplicate my test, and is not multiple. And then I can check all my not assertions. Let's say 5 by 3 and 6 by 4. And here, of course, I need to mention this not multiple. Okay, great. And now I think I've covered everything. Oh, 5 is still not multiple of 3. Thanks for pointing this out. Hooray! So here I got all my my multiple tests and my not multiple test as well. So that's great. So that's great, but is it any useful? Oh, there's a clever one. Is 15 going to be spotted? So we want that 15 is also that 15 is a multiple of 3, but 15 is also a multiple of 5. Yeah, okay, that's good. So if it works with like just simple numbers and larger numbers, it should perform equally well with a much larger number like 1000. So here, yeah, this is not super idiomatic, because the equals 0 is the opposite of, like, if something is equal 0, the truth value is false. So if you're casting a boolean, so for example, if you run a Python shell and if you're testing the boolean value of false, of course it's false. If you do the same with 0, it's also false. If you test with an empty array, it's false. If you test with an empty tuple, yeah, it's false. If you test with an empty dictionary, it's false also. If you put something in an array like 1, 2, or even just 0 and then 0, it's also true because it's not an empty array. So that's what we call the truth value. And here, something being equal to 0 is also something which has a truth value being false. So if we reverse it, like we want that number modulo factor is equal 0, or we could say we don't want a remainder of the division of number by factor. And then, so this is already a better construct, but we've done some change in the code, so let's run the tests again just to be sure that we didn't break anything. Oh, that's good, that's good. So now, can we make it even better? So here I've got the 3-line test. Can I just... Okay, so now I return if there is no remainder of number by factor, and I think that's the shortest way of writing is a number multiple of another. Let's try our test. Still good. So that means that we came with a naive implementation of this. Like we started with the rules. Okay, what are the rules? 3 should be divisible by 3, 5 by 5, 4 by 2, 15 by 3, and so on and so on. But 5 should not be by 3, 6 shouldn't be by 4. And the rules don't change. We change the code around, but we don't change the rules. As long as the rules don't change, we can, and the tests are still passing, then we know that we didn't break anything. So let's continue. Now we want to have the sum of these multiples, just to be sure that if we take the sum of all these numbers, which are multiples of 3 and 5 below 0, we get 23. So how do we do this? So here, if I say tests, it sums correctly below 10. So now I should get some multiples below 10, which is a good way of writing it. Should be equal to 23. So now I've written a test that says test it sums correctly below 10. And what does it say? It says I kind of repeat my assertion, but like here, not with text but with code. I just say, okay, assert that the function sum multiples below 10 returns 23. Okay. So let's run my test again. Oh damn, what's happening? Test it sums correctly below 10. Oh, sum multiples is not defined. Same problem as earlier. Easy fix. Oh, dang. I don't know of a sum multiples function. Yes, sir, it's because I didn't write it yet. So, okay, and from our test, we see that it's going to take a below parameter, which should be below. But I still have no idea what it should do. So let's pass. Oh, great. So it worked. It called the function returned none. Oh, okay. So there's my below here. What it should do is listing all the numbers below a certain threshold. So if you want to generate the integer values below a certain threshold, the easiest way is to use the range function. And the range function, you could pass it the below parameter we got here, and it's going to generate all the numbers below, between 0 and below. So for number in range of below, if is multiple of number 3 or 5, then so here I could use either an accumulator or I could use just a simple counter. So here I'm going to use an accumulator just to make some sanity checks afterwards. So I'm using an accumulator and I'm just saying accumulator append number. So I state it again. For every number below, if this number is a multiple of 3 or a multiple of 5, which is like we need to really pay attention to every single word. So if there are multiples of 3 or 5, it could be of 3 and 5. But here it's 3 or 5, so it's important to get this right. The sum of these multiples is 23, so I'm only capturing the multiples of 3 and or 5, and I'm putting them in my ACC list. Then I can just simply return the sum, which is a built-in function of ACC. Would that work? Yes, that works. So if I assert the sum of my multiples below 10 is indeed 23. That's great. So now the question is how much does it make below 1000? So we can just copy paste this one again. 1000 equals good question. Is it equal to 23? I doubt it. So it looks like the actual answer is 233,168. So probably this would be the answer. So we are just going to replace this in my test. Okay, all my tests are passing. But yeah, so this is how you can write some of the multiples below 1000 in Python. Well, I hope that you found it interesting and that you learned a few things. See you next time!